Welcome to qnawire.
Okay, in this problem, we have a list of particles and their respective speeds. We have two 10 meters per second particles, seven 15 meters per second, four 20 meters per second, three 25s, six 30s, one 35, and two 40s. We're asked in part A to find the average speed, v bar. We're then asked in part B to find the RMS speed, root mean square speed. And in C, we're asked to find the most probable speed. So let's jump into it. We need three definitions. For part A, we need the definition of an average speed. The average is simply the total 1 over the total number divided by the sum of all the speeds. So from I equals 1 to n, this is the definition of an average. For part B, to get a root mean square, as the name suggests, we need to do it, we get the square root of an average of squares. So we're dealing with this. And the most probable speed is simply the one that has the highest occurrence, which goes without saying. Okay, so let's do these computations. They should be relatively straightforward. So for part A, the average is going to be, there's a total of 25 particles in this group. We have two 10s. Two 10s plus seven 15s plus four 20s plus three 25s plus six 30s plus one 35. You get the idea. And lastly, two 40s. So once we add up all of these, divide by the total number of 25, we will be left with a result of 23 meters per second, and that's the average speed. So all we're doing here is the definition of an average for a group of things. The RMS, the root mean square, is similar but a little bit more complicated. Not too bad. We have to take a giant square root. I'm just going to call it say it's this result to the 1/2, which is a square root. We're dividing, once again, 20 by 25 because that's the total number. The only difference is that now we have to square everything. We have 2 times 10 squared. We have 7 times 15 squared. 4 times 20 squared. 3 25 squared. 6 30 squared. And you get the idea, but I'll do it for clarity. 1 35 squared and 2 times 40 squared. We're just multiplying the number of occurrences by the square of the value for that occurrence. So if we compute this, we will end up with a result of 25 meters per second, about. And that's the root mean square velocity for this collection of particles. Lastly, the most probable velocity is simply the velocity that has the most number of occurrences. So let's take a look at this list. You can just look at the list in the sum. There are two 10s, seven 15s, four 20s, three 25s, six 30s, one 35, and two 40s. The most probable speed is the one that has the most occurrences. So that appears to be 15 meters per second because there are 7 occurrences and there's no other case that has more than that. So most probable is 15 meters per second. And that wraps up the problem, just using some definitions.